session today, we will be having graphs of polynomial functions using Desmos application. Now, to begin with, let's first explore the different end behaviors. Again, let's explore the different end behaviors. Let's begin with our Desmos application. There you go. So I have already prepared 8 polynomial functions over here. So I have grouped them also according to their properties. And let's describe each one of them. The first thing that we will gonna do is this one. We will be determining the degree of the polynomial, after which, let us determine the sign of the leading coefficient. Again, we will be determining the degree of our polynomial, and after which, we will be identifying or determining as well the sign of the leading coefficient. Now, let's begin. Let's have our first polynomial. What is the degree of your first polynomial? It's 3. Take note, the degree is simply the highest exponent. The highest exponent here is 3. For number 2, what is the degree? 3 also. Number 3, what is the degree for number 3? 5. The degree for the third one is 5. What about the fourth one? It's 7. Now, you have noticed that 3, 3, 5, and 7. What kind of numbers are 3, 5, and 7? They're odd. That's a very good answer. Odd numbers. So take note, kanang 1, 2, 3, and 4, all the degrees are odd. Now let's go to numbers 5, 6, 7, and 8. What is the degree of number 5? 4. Number 6, what's the degree? It's 6. What about the 7th polynomial? 4. The 8th polynomial. And you have noticed that the degrees are all even. So I have grouped this. The first 4 are odd. The next 4 are even. Next, let's determine the leading coefficient and the sign. The first one, what is the leading coefficient? What is the sign of 1? Positive. So take note, number 1, odd degree, positive leading coefficient. Number 2, what is positive 1? Number 3, negative 1. Number 4, negative 1. So, diri mag-differ. Ang number 1 and 2, ang number 1 and number 2, they are both odd and both are having positive leading coefficients. Ang numbers 3 and 4, both are odd still, but their leading coefficients are both negative. Next, let's go to number 5. What is the leading coefficient in number 5? And what is the sign? Positive. Number 6. Positive 1, it's still positive. 7 and 8, what are the leading coefficients? Both are negative. So, a number 5 and 6, both are even and having a positive coefficient. Ang 7 and 8, both are even but are having a negative leading coefficient. Now, let me show you the graph of number 1. And let's take a screenshot, Ani, because we will be having this in here. Okay, let's just focus on one graph over here. Okay, now, diba the graph of any equation, like any function, it extends infinitely. If you will graph like a line or probably a polynomial, it will extend infinitely. So if this one is, I'm gonna change the color first. This will extend infinitely over here. There's an arrow going down. This one extends infinitely as well. Okay, let's now focus on the different arrowheads. The first arrowhead, I mean, what is the direction of the first arrowhead? This one. Down. But down siya, sir. Let's write the word down. What about the second arrowhead? What's the direction? Up. So the first end behavior is what you call the up-down end behavior. Let's go back to our Desmos application. So this one tells me down, up. Again, pilay degree ani niya class? Pilay degree? The degree of the first one is 3. It's odd. Take note, the degree is odd. And what is the sign of the leading coefficient? It's positive. It's 1, it's positive. Now, let me show you the graph of the second polynomial. What have you noticed with the graph of the second polynomial? Is it the same as number 1? Like, ang number 1 nako, this is down, up. If I'm gonna go to number 2, is this down, up? Yes. No. How do you... Why? Is it up, down, or down, up? Down, up. So, take note. If I'm gonna show both of these, let me show both. You have noticed that ang first niya nga arrow is going down. Ang second arrow niya is going up. And this is what you call an up-down... No, a down-up end behavior. And a down-up end behavior, ang characteristic ani niya is this. Odd ang iyang degree, positive ang leading coefficient. So, tanang odd nga degrees, tanang na ay positive leading coefficient, it will give you a graph that goes down first, and then the other arrow goes up. Mauni siya'y down, up, end behavior. Now, let me show you the third one. What have you noticed now? Up, very good. Up, down, and behavior. The same thing as number 4. This is up, down, and behavior. So therefore, if I'm gonna be showing both, sir, meaning sir, if I'm gonna be having an up, down, and behavior, how do you describe the degree and the sign of the leading coefficient? Anyone? That's very good. Sir, negative ang leading coefficient and ang degree odd. So take note, nanan mo'y duha ka buok nga end behaviors. Ang first end behavior is down, up, positive leading coefficient, odd degree. Ang second end behavior is up, down, negative ang leading coefficient, odd ang degree. Next, what have you noticed over this graph? Number 5. Ang arrow, kini lang siya, kinira maura man ni atong end up, up. Okay. Ayaw na ni pag-matter kay kini siya, it's just part of the graph. I'm referring to the mga endpoints niya ba? Ang end ani ug ang end ani, it goes up. Both goes up infinitely. It will extend infinitely. The same thing, tanawa sa ninyo ang number 6. What have you noticed with the 6th polynomial? What's the end behavior? It's still up, up. So what is now your conclusion kanus aman ta maka up, up, and behavior? I agree with that. If the degree is even and the sign of the leading coefficient is positive, then the graph will always be an up, up, and behavior nga graph. Even though nga, sir, bisag dili na nimo i-graph, sir, I can tell the end behavior right away. Bisag dili nini mo i-graph, sir, I can tell the end behavior right away by just considering the degree and the sign of the leading coefficient. Let's go to number 7. What do you think? Oh, look at the graph now. What is the end behavior of the graph? Down, down. The same thing with number 8. Look at number 8. It's still a down, down. Down, down. Okay? So number 7 and 8, what makes a down, down end behavior? Okay, even degree, and the coefficient of the leading coefficient, the sign of the leading coefficient, I mean, is negative. Now, let's summarize everything. Let's go back to our presentation. Let's summarize the end behavior first. Okay, daghan pa ni siyag mga characteristics. Let's go here. So, if I'm gonna give you a graph like this, what is the end behavior for this graph? Up, up. What is the degree? Is it odd or even? It's even. Okay. And what is the sign of the leading coefficient? Positive leading coefficient. Okay, let's have another graph. This one. This is a down, down end behavior. And what is the degree here? Is it even or is it odd? Even. It's still even. And what is the sign of the leading coefficient? Okay, here's the thing. If both have the same direction, expect that you have an even degree all the time. Again, if both have the same directions, ani, going up, up, going down, down, expect that the degree is always even. Now, if it's both up, up, then the leading coefficient is positive. If it's both down, down, then the leading coefficient is negative. Okay? Now, let's make use of a pen. Next, what about this graph? What is the end behavior of this graph? Down, up. And what is the degree? It's odd. What about the sign of the leading coefficient? It's positive. Now, going here, this positive here, asa ko na i-relate sa graph, sir? Ang ikaduha nga arrow. If ang ikaduha nga arrow will tell you if the leading coefficient is positive or negative. Since that's going up, mao na siyang, di ba, going up, up is positive. Mao nang positive leading coefficient. And take note, when I say odd degree, dili na parihas og end behavior. One is the opposite of the other, either up, down, or down, up. Let's have another graph. This one, what's the end behavior? Up, down. This is still an odd degree, and you have noticed that the coefficient is negative because the second arrow is going down. It tells me that it has a negative leading coefficient. So just given the graph, you can write away, this graph, ang iyang leading coefficient is negative. Ang iyang degree kay odd. By just giving the graph, you can describe those things. And you can tell that this is an up-down end behavior. This one, for the first graph, it will tell me both are going up. So it's an even degree. Okay? Since both are going up, positive leading coefficient. If both are going down, it's an even degree. And both are negative. I mean, both are going down, therefore it's a negative leading coefficient. So that's how you tell or describe the graph using the leading coefficient and also the degree. Any questions about the end behaviors? Is this okay? Everything's clear about the end behaviors this time. Let's focus on the roots. By the way, are there any questions? None so far. That's good. Let's go to exploring roots and zeros. When I say roots or zeros, I will be playing with the multiplicities here. Let me show you another one that I saved a while ago. Okay, there you go. So I prepared 4 examples and I have somewhat written it in factored form. I am writing it in factored form because using these factors, I can tell the roots or the zeros. Let's consider number 1. If I'm gonna give you x plus 2 raised to 3 or cube, how do you write your root for number 1? No, it's not x squared. How do you write your root? Diba, you will be writing the opposite, negative 2. How about the exponent? Unsa may gamiton na kong a word? Negative 2. Multiplicity, very good. I will now make use of multiplicity. So when I talk about the roots or the zeros, multiplicity plays an important role sa graphing nato. Look at number 1 and number 2. Ang multiplicity ani is simply the exponent. Pilay exponent sa number 1? 3. Pilay exponent ani class? Kining x minus 1? 1. Pilay exponent sa x plus 2? 1. Pilay exponent sa x minus 2? Okay. So, kining number 1 ug number 2, ang tanang exponent niya kay puros even or odd? Ang odd. So, meaning, ang 1 and 2, sir, are having odd multiplicities. Again, di ba ang number 1, this is read as a root, negative 2 multiplicity 3. If I'm gonna be writing the roots for number 2 using multiplicity, this is positive 1 multiplicity 1, negative 2 multiplicity 1, positive 2 multiplicity 1. Look at the graph. This is the graph for the first one. I would like you to examine that first. Yeah, you keep your observations. I'll be asking you later on. Next, look at the graph of number 2. If I'm gonna go back to number 1, pilagay itong root nato aning number 1 class. If I'm gonna go to the graph, what point is this? Diba this is negative 2 sa x-axis? Am I correct? Yes. So therefore, sir, ang root di ay, sir, og kanang part sa graph, sir, nga naa makita sa x-axis, mao din ang root nato, sir. Yes, it is. If I'm gonna examine the second one, look at this. Kini siya. Opposite ana, sir, positive 1. Sir, darang positive 1, sir. Sir, sunod, sir. Kini, sir, negative 2, sir. Darang negative 2, sir. Sir, ang negative 2, mahimong positive 2, dara, sir. So, kini dieng 2, kining 1, o kining negative 2, these are the roots which we determined a while ago. Again, kining 1 ug 2, odd multiplicities. O atong ipakita ang number 3. This time, pilay multiplicity sa number 3. Sa number 4, pila. They are even, right? So, number 3 and number 4 are having even multiplicities. I'll be showing you the graph now. So, ang root niya ani is positive 2. Sir, dera, sir, positive 2. My question, parehas ba siya sa behavior ganiha sa number 1? Unsay kalahian aning 1 ug ang 3? Sige, anita sa number 1. How do you describe the odd multiplicity? How do you describe with respect with the x-axis? It starts with the letter I. I, N, T, in. Okay, that's the correct word I'm looking for. Intersect. Tanawan ninyo ang graph sa number 2. Sir, ni-intersect sa x-axis. Ni-intersect sa x-axis. ni intersect sa x-axis. Kanang tulo ka points ni intersect na sila nga naman. Odd man ang multiplicity. So, basta di ay odd ang multiplicity, mo intersect na siya sa x-axis. Look at number 3. Ni intersect na siya, class. Wala. Unsa man na siya, ni unsa man. It starts with the letter T. T-O-U. Sige. Ni T-O-U. T-O-U-C. Sumpahin ninyo. Ni touch. Kana, ni touch. Ni touch ra siya sa x-axis. Wala siya mo intersect. Ni touch siya ni U-turn, kumbaga. Ni U-turn sa x-axis. The same thing with number 4. Tanawang number 4. Ni touch ra jud siya dire. Ni U-turn siya. Sir, himua daw ning negative, sir. Mupadung siya sa ubos. Kay kabaw naman mo, ana. Yahuman, himuon ko ng positive. May balhin siya sa pikas. So, it's simply playing with that para we will be determining the different properties. Now, balik ta sa ato ang PowerPoint. So, this time, let's summarize the multiplicities, the zeros or the roots. If you're given graphs like this, is this odd multiplicity or even multiplicity? That's an even multiplicity. Kay take note, ni touch ra na siya din ha, ni touch ra siya sa x-axis. Ni touch sa x-axis. So, even multiplicities touches the x-axis. Well, the other one, how do you describe this? Intersect, kay nga naman ni intersect siya, kay odd multiplicity man siya, sir. So, take note, if we have even multiplicity, it will only touch the x-axis. If we will have odd multiplicity, it will intersect the x-axis. Now, let's go to our Desmos again, but this time, let's change daw this, sir. Ato ning usbon. Kini, himuon ko ning 1. Look at what happens. I'll make this 1. Show. What have you noticed sa iyang pag-intersect sa x-axis? What have you noticed with this line? Aside from the increasing, describe the line. It's a straight line. It is a straight line. I'm gonna make this 3. I'm gonna change that to 3. What have you noticed with this one now? Is this a straight line? Ni curve siya, pero ni intersect gihapon siya, right? If I'm gonna change this to 5, look at what happens. Ni curve gihapon siya, pero lapad na iyang pagliko. If I'm gonna change this to 7, ni samot kalapad. If I'm gonna change this to 21, awa, niliko, ni touch, niliko. Ni intersect gihapon siya, pero lapad iyahang pagliko. Maunay implication sa pag-increase sa mga exponents nato diri class. Ibalik nato sa 3. So the same thing with negative or even multiplicity. Tanawan ninyo, ang iyang U, pagka U-turn is perfect. Ganahan ko sa iyang pagkaliko, sir. If I'm gonna change this to 4, tanawan ninyo, nagkalapad iyang pagliko. I-change to 6. Change to 8. Change to 20. Pero niliko gihapon na siya, ni U-turn gihapon na, pero ang iyang pag-U-turn, lapad na kaayo. So, klaro ang mga exponents pag-increase niya. Okay. So, balik ta dire. So, meaning di ay, sir, if ever straight line di ay na siya, sir, it will give me nga a multiplicity anak kay 1 all the time. straight line ni intersect all the time multiplicity kay 1. Multiplicity kay 1, multiplicity kay 1. And that is really true because the exponents here are 1. If I'm gonna have this one, sir, perfect kaayo yung pagliko, sir. Wala siya mo flat, meaning klaro kaayo yung U-turn. O ang iyang exponent anak class kini, that's always 2. Kay kung mo himo na gani siyang mo linya na siya mo lapad like the number 4. Look at that. 'Di ba? Compared to number 2, lahi ra kaayo. So based on the pagtuyok niya o pagliko niya, we can tell 1, 2, 3. Okay? Let's go back to our presentation. So these are the different even and odd multiplicities. Now, let's focus on this graph and this polynomial. So obviously, you are already given a graph. Let us describe the degree. What is the degree of your polynomial function? It's odd. It's 1. It's odd. No, the degree is 3. It's odd. What about the leading coefficient? It's positive 1. It's positive. Correct. So what is the end behavior? Down up. So meaning, sir, kung wala ni ang graph, sir, makadetermine gihapon ko, sir, kung unsay end behavior by just looking at the polynomial. Yes, you can do that. Now, I have already factored this a while ago, Kenisha. I did factoring ani niya, and the factors ani niya are this. Mao ni factors. Do not worry, kay during your performance task making, I will teach you on how to make use of a website, and you will just encode the equation there and it will give you the factors. Unya na siya sa second week nato sa December. Okay? Now, going back to the factors, I already made a factoring on this, and these are the factors. So, based on the factors, let's determine the zeros. You give me the 0 for x plus 2. How do you write the 0 sa... Yes, go on. Okay. -2 multiplicity 1. I agree with that. What is the multiplicity? Is it odd or is it even? Odd, because 1 is odd. If it's an odd multiplicity, therefore, it intersects the x-axis at this 0, -2. Okay? Let's go to the second factor. How do you write the root for the second factor? Okay, 1 multiplicity of 2. Is that an even multiplicity or an odd multiplicity? It's an even. So, does it touch or does it intersect? It touches the x-axis at 1. Okay? Let's go to another example. Number 2. This one over here, you're given the graph and also the polynomial function. So we have here, what is the degree? 3 and it's odd. Correct. What about the leading coefficient? -1 and it is negative. Okay. What about the end behavior? Up, down. That's totally right. Now, let's go and look for the factors. I already did factoring a while ago. Ang factors, I need this one. So, using these factors, let's determine the roots. Oh, you give me the first root. What is our first root based on x plus 3? Okay, -3, multiplicity 1. Now, take note, I am just writing multiplicity 1 there para makita nato nga odd na siya or even. Pero inigsuwat ninyo sa mga roots pohon, pwede ra jud na -3. Ayaw na butangig multiplicity 1 because it's understood nga multiplicity ana 1. I am just emphasizing that over here para you can see that it is odd multiplicity and it intersects at the 0 negative 3. Okay? What about the second factor? Correct. Positive 1, multiplicity 2. And that is an even multiplicity wherein it touches the x-axis at this point. Okay? Let's have our third example. This one. That's the polynomial function and the graph. Okay. What is the degree? 4, it's even. What about the leading coefficient? It's positive 1. It's positive. And what's the end behavior? Up, up. Okay, next. I have already factored this, and these are the factors. Now, first, let's consider this one first. Kini atong unahon. Unsay roots ani if ever I'm gonna focus on x plus 1. You give me the roots. Correct. Negative 1, multiplicity 1. Kana mao ni siya, mao ni partner. Okay? Take note, that's an odd multiplicity. It intersects the x-axis. Now, next. Kini siyang x squared. How do you write the roots for x squared? Kung wala siya'y number like walay x plus 1 or y x minus any number, it's only x or x squared or x cubed. Pila may root or 0 ana niya? Class, what are you going to write? The number? What number are you going to write for x squared? For the root of x squared? I will not be having negative 1. You write 0 for that. Again, kung wala gani number nga partner dira class, like x squared na alone, x or x cubed or x raised to 4, the root there is 0. Is that clear? And the multiplicity is the exponent 2. That's an even multiplicity. Therefore, it touches the x-axis. Next, the last factor. How do you write the 0? 2, multiplicity 1. That's an odd multiplicity. It intersects the x-axis. Okay? Next, let's go to the last example over here. The degree is 4, it's even. The leading coefficient, it's negative 1, that's negative. The end behavior, that is down, down. I already factored this out a while ago. These are the factors. Considering the first factor, how do you write your root using this? You'll have negative 1 multiplicity of what? 3. And that is an odd multiplicity. Therefore, it will intersect the x-axis. The second root, which is, or the second factor, which is x minus 2, will give us roots of 2, multiplicity 1, which is an odd multiplicity gihapon, maunang ni-intersect siya din. Are the 4 examples clear? Let's summarize everything now. So the end behaviors, these are the different end behaviors. Up, up, even degree, positive leading coefficient. This is an example. The second one is down, down. You tell me the degree and the leading coefficient, please. Even degree and negative leading coefficient. Correct. And this is an example. What about this one? Down, up. Odd degree, positive leading coefficient. I agree with that. There you go. That's an example of a graph. Last one, up, down. Odd degree, negative leading coefficient. This is the sample of a graph. Okay? So all we need to do is ang degree ra jud, determine whether it's even or odd. And then, ang sign sa leading coefficient, para makabalo ka kung up, up ba na, down, down ba na, down, up, or up, down, without even showing the graph. Okay? Let's go to the multiplicities. We have this one. Unsa gani nga multiplicity class? Even multiplicity. Nganong even multiplicity man saya? Nag-touch raman siya sa x-axis. Correct. What about this one? Odd multiplicity. Why? Intersects the x-axis. I agree with all of you. Okay?